Okay, so this is lesson 2.2c, and we're going to assess normality. We're going to look at normality a little differently, a little different way of testing it, two different methods really. And so in the past, all we've said is, does it pass these three things? Is it roughly symmetric? That data looks roughly symmetric. Is it unimodal, single-peaked? Yeah, that looks single-peaked. And somewhat bell-shaped. That seems to pass the eye test there. Probably approximately normal. But we can dig deeper. And so this digging deeper, sometimes they ask us to, remember the empirical rule that this one standard deviation is 68%, two standard deviations is 95%, and three standard deviations is 99.7%, right? So we're going to actually count how many data pieces are within one standard deviation. So if you look at the given mean here and the standard deviation, if you add and subtract that from the mean, so we get these two numbers, 126 and 87. That's within one standard deviation, 126 and 87. So 87 is right around here. 126 is right around there. So all of these data values are within one standard deviation. Well, how many data values are there? So let's actually count them. Just a second, I'm going to count. Okay, so I tried to count each column. Hopefully I did that correctly. I found 17 in the first column, 29 in the second, 10 in the third, and 2 in the last column. So a total of 58 pieces of data out of 77. It says there's 77, so 58 divided by 77. Hit Control Enter or put a decimal in there to get a decimal. So that's 75% of the data. I was hoping for 68% or something very close to 68%, so that's not... that doesn't make me think this is going to be, let's just keep going, but I'm not thinking this is looking good. Okay, so now if we do the mean of 106.883 plus the standard deviation, or 2 times, and we're going 2 standard deviations out, 2 times 19.484. So if we do that, and if we subtract that as well, so I get 67. 67 would be, let's see, did I do that right on the last one? Oh, wow. I was thinking that was, I think I have to add some more pieces of data. So the first one was 87. This is actually 90 right here. I was thinking 85. 87 includes these pieces of data as well, so I didn't count that the first time. Wow. Okay, so 1, 2, 3, 4, 5, 6, 7. So there's 7 in that column. Let's just make sure. 126 is actually right here. So these pieces of data are not included. Wow, I really messed that up. Sorry about that. This is 130 right here. 126 is before those two. So let's redo that 58. So this should have been, let me go back to this one just for a second. So I don't need the 2 there. And I should have added 7 plus the 17, right? So actually there's 63 pieces of data. This is worse than I thought. So 63 divided by 77. Oh my goodness. So we were hoping for 68%. We got 82%, about 81.8% within one standard deviation. This is not a good start here. Okay, 67, now that I know how to read this thing, 67 means, so I've got these, I'm adding these 3 pieces of data to the second standard deviation. And then 145 would be right here, so these 3. So we're adding 6 to that 63, so that'd be 69. So 69 divided by 77, 89. So again, what did we want? We wanted, we've got 82, this is 82 and 89. So 82%. 89%. We wanted 68 and 95. This is not looking great. Let's go one more standard deviation just to see how bad this is, but we kind of already know this is not going to be a fit. So I'm going to do this, but just go 3 standard deviations out. So if I multiply by 3 there, and add multiplying by 3. So that probably covers everything. 165, yeah, that covers that. And 48, this is 50. I have to get that in my brain here. So 48 is below that. So I add 3 more, add 3 more, and that is 77 out of 77. Well, 77 divided by 77 is 100% there. So this is 100. So that the only one that seems acceptable is, yeah, that's pretty good. But the other ones, this data is not approximately normal. So doing a deeper dive, you can kind of test it out and go, well, this data, it just doesn't look normal there. So it's just not going to work out because it doesn't fit what we expected there. So let's try this. So this is our IQ scores normally distributed. So this is a bunch of real IQ scores from 60 randomly selected 5th graders. And so let's just kind of see what this data looks like. We need to type this in our calculator. So you're going to get your calculator out, and you're going to go to the Helm key, go to List in Spreadsheets. In the top, maybe type IQ. I like 2 letters or more when I do a list. And then just start typing 81, 82, and you type all this data in. I'm going to save you that trouble. Okay, hopefully I typed in that data correctly. I typed in 60 pieces of data. There are 60 pieces of data. That's good. So you want to run out your one variable stat. So hit the Home key, go to Calculator page, go Menu 6, 1, Menu 6, Stat Calculations, one variable stat, say OK. Choose the list, which in this case is called IQ, or just type IQ, press Enter. So it gives me like a mean of 114.983, standard deviation of 14.8009. Kind of gives you all the numbers you need there to look at. So you got your one variable stats there. That's the data, and I did do that right because it matches right there. Those are the same numbers we got there. So now we're going to figure out, again, we're going to do a couple different methods. So let's use the method we just talked about, which is kind of checking each one standard deviation out and see how close that is. So to check that, I'm going to type in our mean, which was 114.983 from the chart there, plus 14.801 is our standard deviation, and then minus that as well. So we're going to subtract that to get our 2 numbers. So we get 129.784 and 100.182. So you just kind of see here. So anything above 100, so kind of these numbers right here, and anything below 129.7. So here, so all of these numbers right here would be in the first standard deviation for this data. So if you count those, I'm going to count the ones that aren't in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 60 minus 18 is 42. So 42 divided by 60. Let's figure out what that is. So 42 divided by 60. It's not bad, right? We're looking for 68%. We got 70%. I can live with that right now. That's pretty close so far. I'm thinking this might be approximately normal. Let's go 2 standard deviations out. So if we take those 2 things we did where we did 1 standard deviation, we're just going to multiply this by 2 and copy and paste that. So now we're between 85.3, so that's also including these, and up to 144 point something, so also including these. So that I don't have 3 of them, so all but 3 of them, so there would be 57 out of 60. So let's hope that's close to 95, so 57 divided by 60 is, wow, this is really nice. And then if you go 1 more standard deviation out, okay, so 70 includes everything, 159 includes everything. So then that'd be 100%. So we're at 70, 95, and 100. That's very close to 68, 95, 99.7. So I feel very confident this is a nice, approximately normal distribution here. There's another way to test. What we just learned, that method will be tested on, or could be tested on AP tests, but there's another way to do this, and that's called a normal probability plot. So it's this, the calculator's going to kind of do it for us. This is above the level of AP. They don't expect you to have done this, but they kind of do this plot, and if the data looks linear, so here's what you do. So you get your calculator out. We can, of course, graph this data. We have it in our calculator, the IQ data. So if you go to listen or data statistics page, go to IQ. You can even do, I sometimes like to take it, a histogram is really nice for shape. It's hard to tell from that if it's normal, right? But we can do another thing if you didn't see this. So menu, plot type, normal probability plot. So if the data, what I mean by the data are the dots there, all the different points. If those look somewhat close to that linear line, and they roughly do, then you can say this data is approximately normal. So just kind of looking at that, and you can just kind of tell that, hey, this data is approximately normal. Don't say it's normal because it's linear. You would have to, we don't use it in math class. So the distribution of IQ scores is approximately normal because the normal probability plot is fairly linear. This is example, this is number of siblings of data. Do you see how this is kind of curved here? If I put a linear graph on this normal probability plot, it doesn't look straight. It looks curved, non-linear. So in this case, this would not be a normal distribution. And it looks like it, doesn't that look skewed right? I mean, you can kind of tell, but the normal probability plot would tell you that. So if it's skewed right, it'll have a curved look to this typically. And so that's not gonna work out. That's not gonna be, you can just look at the normal probability plot. It's an advanced way of doing it, but the calculator kind of does most of the work for you if you do it that way. So it's kind of a nifty move. I wanted to show it to you so you can use that reasoning if you want. You can use the reasoning even though it's above the level of APSTAT. Still fine to use that reasoning to prove something's linear. As long as you mention the fact that you're talking about a normal probability plot, don't just say because it is linear, actually because the normal probability plot is fairly linear. I like even the word fairly. It's not perfectly linear, but it's roughly linear.